Welcome students to online classes of mathematics for class 9th. In this video we are going to study the chapter number 7, which is triangles of NCERT textbook, and we will be covering the exercise 7.3. This is the session number 4 for this particular chapter. Myself Deepak Kodam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's begin with today's class. The topic that we are going to study is some more criteria for congruence of triangle, in which the first is the theorem 7.4, which gives the SSS congruence rule. SSS means side, side and side congruence rule, which says if three sides of one triangle are equal to the three sides of another triangle, okay, which simply means if three sides of one triangle are equal to the three sides of other triangle, then the two triangles are congruent. Okay, so here we are talking about the three sides of one triangle equal to the three sides of other triangle. Okay, that's why it's called SSS congruence rule, side 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 congruence rule. Okay, if it is the case, then the two triangles will be called congruent. Okay, you can see it from the figure. Let's draw a figure. This is a triangle. Let's name it ABC, and we have another triangle. Let's name it DEF. Okay, considering that these two triangles are having side AB equals to DE, side BC equals to EF, and side AC is equal to side DF. Okay, that means the corresponding side of AB is this DE. Similarly, the corresponding side of BC is this EF, and the corresponding side of AC is DF, and all three are equal. Okay, if that is the case, so write if AB is equals to DF, so DE, BC is equals to EF, and AC is equals to DF. Okay, then triangle ABC will be congruent to triangle DEF. Okay, if the all three corresponding sides of a triangle are equal to the three sides of other triangle, then the two triangles will be congruent, and this congruent rule is called side 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 congruence rule. Okay, in short, SSS congruence rule. Okay, now moving ahead to next one, we have next is theorem 7.5, which is commonly called as RHS. In this, R stands for right angle, R stands for right angle, S stands for hypotenuse, and S stands for side. Okay, so this is right angle, hypotenuse and side congruence rule, which says if in two right triangle, okay, so you can notice from here that we are talking here about the right triangles. Okay, if in two right triangles the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent. Okay, which simply means we are having the two triangles here in which, and both triangles are hypotenuse triangle. Hypotenuse triangle means one of the angle in them has to be of 90 degree. Okay, so we have two right triangle in which the hypotenuse is the side opposite to the right angle. So hypotenuse and the one side, that one side can be the any of the remaining two side. Okay, or one triangle is equal to the hypotenuse and the one side of other triangle. Let's understand this with the figure. Let's do a right triangle. ABC first. Okay, let's name it ABC, right angle at B. Okay, then draw another right triangle. Name it DEF, which is D, E and F. Okay, this is right angle at angle E. So now we have this two right triangle. Okay, as this theorem says, in two right triangle means there has to be one angle of 90 degree in each. Okay, so we have angle B equals to angle E, so we got one thing equal, that is angle B is equals to angle E. So from here RHS we got R. Then hypotenuse, That means the hypotenuse AC of triangle ABC and the hypotenuse DF of triangle DEF has to be equal. If they are equal, so AC is equals to DF. Okay, let's write it. If angle B equals to angle E equals to 90 degree each, and the hypotenuse AC is equals to hypotenuse DF. Okay, and now we can take any of the remaining side. You can take either AB and its corresponding side DE, or you can also take BC and its corresponding side EF. If any of one pair of side is equal, this can be AB equals to DE, or it can be BC equals to EF. Okay, if you find any one of these two, AB equals to DE or BC equals to EF, in that case that this will be right angle hypotenuse and this will be one side. So by Rhs congruence rule, then the triangle ABC will be congruent to triangle DEF. Okay, so one thing that you have to remember, that this theorem or this congruence rule is applicable only right triangle. Okay, this is applicable only in right triangle. It will not be applicable in other type of triangle. Okay, so these are the theorem 7.4 and 7.5. Now based on this we have exercise 7.3. okay, let's move to the exercise. Now the chapter 7 triangle, we have exercise 7.3. in this exercise we have total 5 questions, so we'll be covering all the 5 questions in this video. So first one is, triangle ABC and DBC are two isosceles triangles. So we have here two triangles ABC and DBC, and both are isosceles triangles on the same base. It's also given that the triangles are on same base. Okay, then the vertices A and D are on the same side of BC. AD is extended to intersect BC at P. Okay, so simply what we have here is, we have two isosceles triangles. Let's say this one first is ABC. Okay, and there is another isosceles triangle which is DBC, and they are on the same base BC. So if this is A, B and C, and this is the common base BC, on the common base BC we have another triangle which is DBC, D, B and C. Okay, this is the point D. So these are the two triangles given. Then it's further saying that vertices A and D are joined. These two vertices A and D are joined, and this is AD is extended to intersect BC at point P. That's how we got this figure. Okay, so initially we have two triangles. First triangle is triangle A, B and C, and the second triangle is triangle D, B and C. Okay, so we have these two triangles, and we have to prove 4 things. First is triangle ABD congruent triangle ACD, ABP equals to ACP, and we have to prove that AP is bisecting angle A and angle D. Also AP is perpendicular bisector of BC. Okay, these are the 4 things we have to prove. So let's first start with writing the given part, because that will help us in the solving the question. So first is, given here is two isosceles triangle ABC and DBC. Given is two isosceles triangles ABC and DBC in which, or you can first write ABC and DBC on same base BC, such that in which A and D are joined and extended to cut base BC at point P. Okay, so we have two isosceles triangle, namely ABC and DBC, which are on the same base BC, in which let's write vertices A and D are joined and extended to cut base BC at point P. Okay, this is what given to us in the question. Okay, now we have to prove four things. To prove is, first we have to prove that triangle ABD is congruent to triangle ACD. Then second, we have to prove that triangle ABP is congruent to triangle ACP. Okay, then third one is AP bisects angle A as well as angle D. Okay, as well as angle D. And the fourth and the last one is AP is perpendicular bisector of BC. That means AP is perpendicular on BC and also it is bisecting the BC in two equal parts. Okay, that's what we have to prove in the part 4. Okay, so let's start the proof one by one. Okay, proof 1, we have to prove that APB equals to ABD is congruent to triangle ACD. So first locate the two triangle. ABD is this one, ABD is this triangle, and ACD is this one. Okay, so you can see that we can apply here the which theorem. We can apply the congruency rule of side, because as ABC is a congruent isosceles triangle, so its corresponding side, this AB and AC, will be equal. Okay, similarly, since DBC is also an isosceles triangle, so its opposite side BD and BC will be equal, and the third side, this AD, is common for both triangle. So by this side congruence rule, these two triangles will be congruent. Okay, so we'll write in triangle ABD and triangle ACD, we have is the side AB is equals to side AC. Reason for this one is ABC is isosceles triangle. That's why its opposite side will be equal, and the side DB, we can say DB is equals to DC. Again, the region is triangle DBC is isosceles triangle. Okay, so both are the equal sides of isosceles triangle. So AB equals to AC, DB equals to DC, and the third side, this third one, this ABD is the common for both one. So AD equals to AD, and this is the common for both the triangle. Therefore, by side congruence rule, these two triangles are congruent. So like, therefore, by side congruence rule, is triangle ABD is congruent to triangle ACD. And reason for this one is by side congruence rule. Okay, so that's the proof of the part 1 of question number 1. Now coming to the next part. Here we have to prove that APB is congruent to triangle ACP. So let's erase the first these mark. Okay, the figure given to us here is, now it's saying you have to prove that these two triangle APB and ACP are equal. Let's locate the triangle. APB is this one, A, B, P, and the second triangle is A, C, and P. That means these two triangles. Now we have to prove that these two triangles equal. Again, you can see that now we can prove that this one by the side congruence rule, which is here you can see this first side is common, is equal, because the ABC is a isosceles triangle. Okay, in the previous part we have proved that these two triangles are congruent, so their corresponding angle, these two angles will be equal. So we got one side, one angle, and this side AP is common for both of these triangles. Okay, AP is common for triangle ABP and ACP. Okay, so by side angle side these two triangles will be congruent. Okay, let's write the answer. In triangle A BP in triangle ABP and triangle ACP, we have this side AB is equals to AC. Again, triangle ABC is isosceles triangle. Okay, you have to write the region for everything that you're writing in the bracket in front of it. Okay, so we have written that AB equals to AC. A reason for that one is ABC is an isosceles triangle. That we have, since triangle, in the part 1 we have proved this, that ABD is congruent to ACD. So we'll write this, we'll use this, that since triangle ABD is congruent to triangle ACD. Okay, this is proved above, proved in part 1. Okay, therefore their corresponding angle, these two angles will be equal. That is, angle BAD will be equals to angle CAD, because they are the corresponding parts of congruent triangle CPCT. Okay, as we know that the corresponding parts of congruent triangles are equal. Okay, or we can write this as, we can write this triangle angle BAD, extending it from B to P, we can write this as, or angle BAP equals to angle CAP. Okay, because the angle will not change by extending one line. So we got one side here as, so we got one side here as, and the angle here A. Now we look for the third side. So we'll write, and AP is equals to AP, which is common for both triangle ABP and ACP. And so we got the third side here. So by side angle side, so let therefore triangle ABP is congruent to triangle ACP, and that is by side angle side congruence rule. Okay, so we prove the second part also of question number 1. Now come to the part 3. Here we have to prove that AP bisect angle A as well as angle D. So since we have already proved here that these two triangles are congruent and their corresponding angles are equal, so So we can clearly got here from that the AD is bisecting angle D. Okay, so right, since triangle ABD is congruent to triangle ACD, this is proved in part 1. Okay, therefore angle BAD will be equals to angle CAD. Okay, hence AD bisects angle A. Okay, now we'll come to the other part, that AD is also bisecting angle A. This is what we have already proved, that these two triangles are congruent. So we clearly conclude that AD is bisecting angle A, because the angles BAD and CAD are equal by CPCT. Okay, now in triangle B, so we'll take now triangle DBP and DBP and triangle DCP. Okay, we have this side BD is equals to side DC. Okay, BD is equal to DC because they are the opposite side of congruent isosceles triangle DPC. Side DB is equals to DC because they are the opposite side of an isosceles triangle. So this is given because we are given that DBC is an isosceles triangle. Okay, now moving ahead, now we have proved that these two sides are equal. Then we have that the two triangles that we have proven in the part second, that ABP and ACP are congruent, therefore their corresponding side will be equal. Okay, so we have, or we can write, since triangle ABP is congruent to triangle ACP, therefore the corresponding side BP will be equals to PC. Okay, so this is proved in second, and this is by CPCT. Since these two triangles are congruent, their corresponding parts will be equal. Okay, so we got the another side. First side we got DB equals to DC, then we got BP equals to PC. Now DP is common for both triangle, and DP is equals to DP, which is common for both the triangles. So we got another side. So what we got here is side and side. So by Rhs Congruence Rule, these two triangles will be congruent. Okay, therefore triangle DBP is congruent to triangle DCP. Okay, this is by side congruence rule. Okay, hence their corresponding angle, you can say BDP will be equals to angle CDP by CPCT. That means this BDP is also intersecting angle D. Okay, so they can write this implies that DP bisects angle D. Okay, so let's write this one as equation 1 and this one as equation 2. So we'll write from equation 1 and 2, we conclude that from equation 1 and equation 2 we conclude that AP bisects angle A as well as angle D. Okay, that's what we were asked to prove in the part 3. Okay, now moving to the part 4. Here we have to prove that the AP is the perpendicular bisector of BC. We have to prove that this AP is perpendicular bisector of BC. So let's start for this one. Since AP stands on BC, therefore the sum of angle APB plus angle APC will be equals to 180 degree. The reason is because they are forming linear pair. Okay, so the sum of these two angles has to be equals to 180 degree, but we have proved that the angle APB is equals to angle APC. Okay, so we have proved that the APB and APC are equal. These two angles APB and APC are equal. Okay, we have proved that these two angles are equal. Therefore the angle APB equals to angle APC will be equals to 180 degree divided by 2 equals to 90 degree. Okay, that means the measure of each of these two angles is 90 degree. So we'll write also BP is equals to PC. This is also proved above. Okay, this is proved above. So hence we'll write hence AP is perpendicular bisector of BC. Okay, so that's the answer of number 4 of question number 1. Okay, so now let's move to the question number 2. In question number 2 we have that AD is an altitude of an isosceles triangle ABC in which AB equals to AC. We have to show that AD bisects BC and AD bisects angle A. So let's first draw its figure. We are given an isosceles triangle ABC in which AB equals to AC. Okay, let's draw its figure. Okay, so this is a required figure. So first write the answer number 2. In this first mention the given portion. Given here is an isosceles triangle, ABC in which AB equals to AC. Okay, so given is an isosceles triangle in which AB equals to AC, and we have to prove two things here. To prove is, first we have to prove that AD bisects BC, and second we have to prove that AD bisects angle A. Bisects angle A. So we have to prove that this AD is bisecting this BC into two parts. That means BD and DC equal. Then we have to prove that the angle these two are equal. Okay, so let's start its proof. Okay, proof for part 1, where we have to prove that this AD is bisecting the side BC. Okay, that this this altitude AD is bisecting BC into two equal parts. Okay, so let's start with the two triangle ABD and triangle ACD. Okay, so to start, in triangle ABD and triangle ACD. Since we have this AD is the altitude of the triangle ABC, since AD is altitude of triangle ABC, therefore since the altitude, therefore the angle ADC will be equals to angle ADB, and each of 90 degree. Okay, so we got the two angle. Therefore the angle ADB will be equals to angle ADC, and each will be of 90 degree. Okay, so we have these two angle equal and each will be of 90 degree. And since it's given that the given triangle is an isosceles triangle, so the opposite side are given that AB and AC are equal, and we have AB equals to AC. This is given. So we got one angle, one side, and we got this AB and AC is also the hypotenuse of this right triangle. Okay, and also we have AD equals to AD, which is common for both the triangle. So now we can say by Rhs congruence rule, this is right angle, this is this is hypotenuse, and this is one side. So by Rhs congruence rule, these two triangles are congruent. So right, therefore triangle ABD is congruent to triangle ACD. Okay, ABD is congruent to triangle ACD by Rhs congruence rule. Okay, so since these two triangles are congruent, therefore, or you can say hence, side, its corresponding side BD will be equals to DC. This is by CPCT, that is corresponding parts of congruent triangle are equal. Okay, so that's the part solution of the part 1, that AD is bisecting DC. Okay, or you can say thus AD bisects BC. Okay, now come to the part second. We have here that we have to prove that AD is bisecting angle A. So right, since triangle ABD is congruent to triangle ACD, this is proved above in part 1. Therefore this corresponding angle, these two will be equal, that is angle BAD will be equals to angle CAD. This is by CPCT. Okay, or you can write thus BD bisects angle A. Okay, that's the answer of the part second of question number 2. Now moving ahead to the question number 3. Here we have two sides AB and BC and median AM. So here we have two side AB, BC, and the median AM of triangle ABC is equal to the side PQ, QR, and median PN of triangle PQR. Okay, as you can see, this side AB is equals to its corresponding side PQ. Similarly, this BC, this entire side BC is equals to its corresponding side QR, and the median, this median AM is equals to the median PN. Okay, so based on this we have to prove two things. First one is that triangle ABM is congruent to triangle PQ, and ABM is this one and PQN is this one. Okay, then we have to prove that ABC and PQ are also congruent. Then we have to prove the entire triangle, this ABC and PQR are congruent. Okay, so we're going to prove this one by one. So let's start writing its solution. Answer number 3. Okay, first we'll mention the given part. Given is two triangles ABC and PQR, in which this is PQR, in which we have this side AB equals to PQ, in which AB is equals to PQ, side BC equals to QR, and the median AM is equals to PN of the triangle ABC and PQR respectively. Okay, so this is given to us. Now we have to write to prove. We have to prove two conditions here, or two situations here. First one is that triangle ABM is congruent to triangle PQN, and secondly we have to prove that the triangle ABC is congruent to triangle PQR. Okay, so let's start this proof of part 1. Okay, here what we have to prove is that triangle ABM, these two triangle ABM and PQN are congruent. Okay, so here we have in triangle ABM and PQN, in triangle ABM and triangle PQN we have, so in this two triangle we have the side AB equals to side PQ. This is given. Okay, also we have the side AM is equals to PN. This is also given. Okay, but when we are given on the another side that BC is equals to QR. Okay, so we have one more side that BC is equals to QR. Okay, but in this triangle we are not having the entire BC, we are having only till BM. Okay, we are having it only till BM. So what we are going to do is we'll divide this equation by 1/2 on both sides. Okay, so we can write this as or 1/2 BC is equals to 1/2 QR, that is half of BC and half of QR. Half of BC is BM and half of QR is QN. Okay, so now what we got is we got three sides equal. We got this side as and the third side as. So by side congruence rule, these two triangles will be congruent. So right, therefore, okay, so as it is given that these two sides are equal, their half will also be equal. So we got BM equals to QN. So therefore triangle ABM will be congruent to triangle PQN. Okay, these two triangles will be congruent. This is by side congruence rule. Okay, so we got these two triangles as congruent. Now moving to the second part of this question. Now we have to prove that the triangle ABC is congruent triangle PQR. Okay, now write in triangle ABC and triangle PQR, we have what we have here is that side AB is equals to PQ, side AB is equals to PQ. This is given. Okay, then we have this side BM is equals to QN, which we have already proved. Okay, okay, after this, since triangle ABM is congruent to triangle PQN, therefore their corresponding angle ABM will be equals to angle PQN, that too by CPCT, that is corresponding parts of congruent triangle. Okay, so that what we got is that these two angle are equal. Okay, or we can write this angle as, or we can write this angle ABM as ABC extended till point C, and also we can write this PQN as PQR. Okay, so again, so these two angles will be equal, and we are given that BC is equals to the base side QR. Okay, BC is equals to QR. This is also given. So what we got here now is we got one side, one angle, and side. Okay, two sides and their included angle. So we'll write therefore triangle ABC is congruent to triangle PQR, and that too by side angle side congruence rule, by side angle side congruence rule. Okay, so that's the answer of question number 3 of exercise 7.3. okay, now moving to the next question, question number 4, which is BE equals to CF. BE and CF are two equal altitude of triangle ABC. So we have one triangle ABC in which we are having two altitude, which is BE and CF. So you are asked, using Rhs Congruence Rule, prove that the triangle ABC is isosceles triangle. Okay, so we have to use an isosceles Rhs Congruence Rule to prove that these two triangles are congruent. So first row, let's draw its figure. So this is the figure of this question. Let's name it A, B and C, and the altitude will be BE and CF, and they are falling perpendicularly. Okay, so let's start the answer number 4. First we'll mention the given part. Given here is, we are having a triangle ABC. Given is a triangle ABC in which two altitudes BE is equals to CF. That is, it's given that altitudes are equal. Okay, we have to prove that ABCD is an isosceles triangle. Proof is ABC is isosceles triangle. Okay, let's start its proof. It's very easy. We are going to use the Rhs Congruence Rule here. So we'll write, in triangle BFC, in triangle BFC and triangle CEB. Okay, in triangle BFC and triangle CEB, in this triangle we have the angles BFC is equals to angle CEB, and each will be of 90 degree. Okay, each is of 90 degree. So we have BFC is equals to angle CEB, and each is of 90 degree. Then the side opposite to this right angle for both the triangle is BC, and we know that side opposite to the right angle is the hypotenuse. So we have end BC equals to BC, which is the hypotenuse for the both right triangle, and this is common. Okay, and we have the altitudes are given equal. So we have CF equals to BE. This is given. So what we got is, we got a right angle, hypotenuse, and the side this one. Okay, similarly right angle, hypotenuse, and side this one. So by Rhs Congruence Rule, these two triangles are congruent. So right, therefore triangle BFC is congruent to triangle CEB, that too by Rhs Congruence Rule. Okay, and since these two angles or triangles are equal, so this implies their corresponding angle for triangle this triangle, the corresponding angle this angle, and for this triangle the corresponding angle B will be equal. So okay, this implies that angle B of triangle BFC will be equals to angle C of triangle CEB. Okay, this is by CPCT. So since we got the two angles are equal, and we know that from isosceles triangle property that the angles, side opposite to the equal angles are equal. Okay, this implies that this side opposite to angle B is AC, is equals to AB. All right, sides opposite to the, so equal angles are equal, side opposite to equal angle are equal, hence ABC is a isosceles triangle, hence ABC is isosceles triangle. Okay, that's what we were asked to prove, that prove ABC is an isosceles triangle. So first we prove that these two triangles are congruent. By if these two triangles are congruent, their corresponding angle B and angle C will be equal. And from isosceles triangle property, we know that the side opposite to the equal angle of a triangle are equal. Okay, so with that we have proved that these sides are equal, hence ABC is an isosceles triangle. Okay, now moving to the next and the last question of this exercise. Question number 5 is ABC is isosceles triangle in which angle side AB equals to AC. Draw AP perpendicular on BC. Show that angle B and angle C are equal. So first we will draw its figure. Let's name it A here, B and C, and we have this altitude AP. Okay, so let's start its answer number 5. First write the given part. Given here is an isosceles triangle ABC. Given is an isosceles triangle ABC in which AB equals to AC and AP is perpendicular on BC. We have to prove that the angle B is equals to angle C. So we are given that these two sides are equal and the angle here is 90 degree. Okay, as these are the perpendicular on it. Okay, to prove is we have to prove that the angle B is equals to angle C. Okay, let's start this proof now. Proof is in triangle ABP and triangle ACP, in triangle ABP and triangle ACP, we have what we have is we are given that the angle, one angle is 90 degree. Okay, so first we'll write, and we are given one side are equal, that side AB is equal to side AC. This is given. Then we have AP is equals to AP, which is common for both the triangle, and we have angle APB is equals to angle APC, and each will be of 90 degree, each of 90 degree. So again by RHS criteria, okay, so we got this side is, we have right angle, hypotenuse and side. Okay, so by RHS criteria these two triangles are congruent. So therefore triangle ABP is congruent to triangle ACP by RHS congruence rule. Okay, therefore you can write hence its corresponding angle, or you can write this implies angle B will be equals to angle C, will be equals to angle C by CP/CT. Okay, so and that's what we are asked to prove here, that prove that angle B is equals to angle C. So we have proved that these two angles are equal. Okay, by CP/CT. So that's all from this exercise. We have completed all 5 questions. Okay, so that's all for now. Thanks for joining here. Thank you. So that's the answer number 5. That's the answer of So that's the answer of question number 5 of exercise 7.3. With this we have concluded exercise 7.3 and also the chapter 7 triangles. Okay, I hope you understood all the question. Now what you have to do is practice this question multiple times so that you can understand them better. Okay.